Hello, here in this video we're going to look at 9.6, solving using the quadratic formula. We previously saw a video on where this formula came from. And what it's all about is a quadratic in standard form, ax squared plus bx plus c is equal to 0. We saw in the video that if you complete the square and go through all those processes, that you end up with x solved for, and you end up with this particular formula. So that's where the quadratic formula comes from. It's from the standard form of quadratics, where someone used completing the square to solve for x, but they left a, b, and c as a, b, and c. That way we can plug in any a, b, and c's that we want into our formula and get the answer. Now remember what this is finding, because when it says solve, using quadratics, so solving quadratics is this. We got U-shaped curves, right? They could look like this sometimes. Sometimes they could look like this. Sometimes they could look something like that. And what the solutions were the x-intercepts, where it crossed the x-axis. And we saw that it's possible to have two solutions, one solution, and then also it's possible to have no solutions. And we're going to see that the quadratic formula can determine all of that. And we'll see kind of how that works as we move on through these notes. Now, all these solutions, these x-intercepts, are a coordinate point, and it's a number, comma, 0. Which means if we want to use the quadratic formula, we must equal 0. And I went ahead and made the first example here a scenario where we're not equal to 0. We always must be equal to 0 because we're looking for the x-intercepts, where the y-coordinate is 0. So for this one, I would need to subtract 5x from both sides. And so our equation would now look like this. It's equal to 0. We're going to need our a, b, and c values in order to use the quadratic formula. Our a is this invisible 1, our b is the negative 5, and our c is the positive 6. You do ultimately need to memorize the quadratic formula, which might seem intimidating because it's very large, but once you've used it several times on this video, you'll find that it's not as bad as you think. Now, the best way to do the quadratic formula is to write out a blank template just like I'm doing. So what this is the quadratic formula, but I'm leaving space for all of my a, b, and c values. And what this will allow us to do is keep track of negative signs easier. It allows us to make sure we plugged in the right numbers at the right spots. I always start off my quadratic formula like this with the parentheses to help me keep it all straight. So we're then now just going to fill in the values with the proper numbers. So a b value went here and here, and you can see that in the formula up top. Our a values went here and here, and then our c value showed up right there. And so what this is ultimately going to do is this is going to tell us where the x-coordinates for our x-intercepts are. Now, the only way to really mess up the quadratic formula is to do too much too fast. I recommend really taking your time and showing your work. So here's what that would look like step by step. A negative 5 will turn positive. I'm now just going to calculate, what's all this stuff equal to? Negative 5 squared is 25. This piece right here, I'm multiplying three numbers together. I'm multiplying a negative 4 times a 1 times a 6. And if we do that, negative 4 times 1 times a 6 gives me a negative 24. And we're all over top of a 2. So as we continue to simplify, I've now got 5 plus or minus the square root of 1 over 2. Once we get our square root all simplified, what we will want to do is talk about this plus minus. The reason that this plus or minus is here is because anytime we took a square root, in an equation context. So for example, x squared is equal to 9. When you square a root, you need to include plus or minus, because if we think about this equation, both positive 3 and negative 3 will work. So anytime we're doing our quadratic formula, that plus or minus will be there to split our answers into two pieces. And so what we'll do to find those two pieces is we'll just split them off into what those are. So we'll have 5 plus square root of 1 divided by 2, and 5 minus square root of 1 divided by 2. And notice here that the only thing that's different about these two is that they're split up between the positive and negative case, because I needed to account for both of them. Now, the square root of 1 is 1. So here's our setups. 5 plus 1 is 6. 6 divided by 2 is 3. 5 minus 1 is 4. 4 divided by 2 gives us 2. So the quadratic formula, after all that math, found us the x-intercepts. Now, the quadratic formula is a little long. It's very bulky. It does, however, solve any quadratic that has an answer. So anytime that there's a quadratic equation that has a solution, so like this blue one or this green one, the formula will solve for it. It'll find your x-intercepts. It will not find any x-intercepts if your quadratic looks like that, but that's because that one has no solutions. Now, with this, anytime our answer is a whole number or a fraction, that actually means we could have solved this same equation. So I'm just going to write the same equation over again. It means we could have solved it with factoring as well. Right, this one being the easy type would factor to x minus 2, x minus 3. And then using the zero product property, we would get this. And so you can see that solving by factoring and solving by using the quadratic formula gets us the exact same answers, but factoring was much shorter. And that's why we learned that method, because quadratic formula can solve for anything, but it's very long. Factoring was very short. Now, the reason that we still need the quadratic formula is because sometimes our answers are going to be decimals, and factoring won't be able to find them. Only the quadratic formula will be able to find them. So that's why we do need the quadratic formula. And it was similar to completing the square. Sometimes we'd solve a completing the square example, and our answer might have ended up something like 3 plus or minus the square root of 7. That would be a decimal answer that factoring couldn't solve for. And so that's why we'll ultimately still need the quadratic formula. The quadratic formula is also nice for when we have larger numbers that might have taken some more time to factor. So the quadratic formula definitely has its benefits. All right, so let's continue to use the quadratic formula to solve these quadratic equations. So you'll see me do this every single time. We need to set up the blank template to plug in our A, B, and C values. And for this one, our A is the invisible 1, that's with the x squared. Our B is the negative 2, and our C is the negative 8. The quadratic formula says negative B, so we put our negative out front, and then our B, which is also a negative, right there. B goes here as well. A values go there, and the C shows up one time right there. So obviously, if you can't set these up correctly, you'll have a difficult time getting the answers. So I really recommend writing out the blank template just like I did. It also helps you go one step at a time. So now we'll have 2 plus or minus of 4. And this is negative 4 times 1 times the negative 8. Which will be a positive 32 all over 2. So we'll get 2 plus or minus the square root of 36 all over 2. You can go ahead and take the square root now if you want. 2 plus or minus 6 all over 2. And it's now time to split into the positive and negative case. So we'll get 2 plus 6 over 2 and 2 minus 6 over 2. And it's important to understand that you do need to do the numerator first before we do the denominator. So we'll get 8 over 2 to get that x is equal to 4. 2 minus 6 is a negative 4. And we'll get that x is equal to negative 2. Now, as always, if you get whole number answers, what that means is you could double check by factoring and using the zero product property to make sure that you got the same answers. So for this one, for example, it would be x minus 4, x plus 2. And when you use the zero product property, you'll realize that you get x is equal to 4 and x is equal to negative 2, which is the exact same answers that we had gotten right there. So we'll conclude this part 1 by looking at one more quadratic formula. And this is another instance to where we're not set up equal to 0. So I would need to subtract 117 from both sides. All right. So remember what we're looking for on this ultimately is the x-intercepts. That's what solutions are. And so one thing to go back and mention on this previous one, that means that this quadratic crosses the x-axis at 4 and negative 2. This quadratic up here crosses the x-axis at 2 and 3. That's what this is telling us. It's finding the x-intercepts. This one has that minus 117, so it's a larger number, but the quadratic formula doesn't care. It can accept any a, b, and c values, where our a is the invisible 1 again, our b is a negative 4, and our c value is the negative 117. All right, so going one step at a time, we'll get a positive 4 plus or minus a 16, and then we need to do negative 4 times 1 times negative 117. So the two negatives are going to cancel out and turn positive, because negative times negative is a positive, and multiplying by the 1 doesn't change anything. And the 4 times the 117 gives us 468. So then we'll have 4 plus or minus the square root of, and when we add 16 onto that, we get 484. All over 2. Now 484 does have a square root. If you ask your calculator to take the square root of 484, you'll get 22. And now we're ready to split this off into the two different cases, because of the plus minus. We do the numerators first, so we'll have a 26 over 2. This one gives us a negative 18 over 2. So we'll get that x is a 13, and we'll get that x is equal to a negative 9. And those are the two x-intercepts. Those might have been harder to find by factoring because negative 117 is such a large number, and we're not familiar with the factors, but that's what's nice about the quadratic formula, is that it will solve any quadratic formula. It'll tell us where we're crossing the x-axis, no matter how big or small those numbers are.